Hello again, Algebra Scholars. In this second part of section 6.1, we're going to be simplifying rational expressions. And the way we simplify rational expressions is by canceling factors. And it's worthwhile to say here that we are not going to cancel terms. We're only going to cancel factors, and factors informally we will say are things that are multiplied. So you can only cancel factors, we cannot cancel terms. So if there's addition or subtraction involved, that's not something that we can cancel. So as a first easy example here, we have this very simple rational expression. There is no addition or subtraction anywhere in it, so we can feel free to cancel. We see a common factor of 6. It goes into itself once. It goes into 54 9 times. So now we have 9x to the 5th over x. And then we see that the x's can cancel as well. This goes to 1, and this goes to x to the 4th. So this whole rational expression simplifies to 9x to the 4th. Here is a second example, a little bit harder. Let's go with 6x squared plus 3x over 7x squared plus 7x. Now we can't cancel anything here because we have terms on the top and the bottom, and we cannot cancel terms. And so the way we get factors is by factoring, of course. So on top, there's a GCF of 3x, leaving us with 2x plus 1. And down below, there is a GCF of 7x, leaving us with x plus 1. So now I have factors. The first factor is 3x, the second factor is 2x plus 1. I have 7x and x plus 1. Actually, better said, I have 3 times x times 2x plus 1 and 7 times x plus 1. And I make that distinction because it's actually only the x's that we can cancel here. And so what we're left with is 3 times 2x plus 1 and 7 times x plus 1. In this third example, you might be really tempted to try and cancel the 16s or cancel the x squareds, but remember, don't cancel terms. It's tempting to do, but you can't do it. All that we can cancel are factors. And to get factors, we factor. So for the top, we'll make a factor sum chart, two numbers that multiply to 16 and add up to -8. They're -4 and -4. The bottom, I hope you will recognize as a DOS. So the top factors into x minus 4 from this factor sum chart, and I hope you recognize the bottom as a DOS, x plus 4, x minus 4. If it helps you to put the multiplication signs in between the parentheses, do so to remind yourself that you have factors. I'll get out my red pen now, and I will cancel the x minus 4's, leaving me with x minus 4 over x plus 4. And that's as far as that problem goes. In this fourth example, we have all terms, so we're not allowed to cancel yet. We need to do our factoring first. Up top, I wonder if you can see that it looks like this top might be a PST. The first term is positive and a perfect square. The last term is positive and a perfect square. And if we fill in A and B into these parentheses, does the middle term we get here match the middle term in the problem? And indeed it does. So the top of this problem, we know, factors into 2x minus 3 squared, which I'm actually going to write as 2x minus 3, 2x minus 3. The bottom of this problem has no GCF. It requires a factor sum chart, two numbers that multiply to negative 60 and add to negative 11. After a little bit of thought, we can see that they're negative 15 and 4, but this is not a problem where we can go directly to the factored form. We have to rewrite the middle term and use grouping here. So this is going to require a little bit more work. GCF is 5x, leaving us with 2x minus 3. GCF is 2, leaving us with 2x minus 3. We're happy the parentheses match. 2x minus 3 times 5x plus 2. Now we have factors because there's multiplication involved, so we are allowed to cancel, and I see that there is a common factor of 2x minus 3. So the final answer is 2x minus 3, 5x plus 2. The final idea in section 6.1 is the idea of opposites. Opposites are not the same. Opposites look like this: A minus B and B minus A. Normally, the only things you can ever cancel is if it's exactly the same in the numerator and denominator. But if you have opposites, you can say that opposites always simplify to negative 1. But be careful, there are things that look like opposites that are not. Things that look like opposites but aren't. For example, A minus B over A plus B, those are not opposites. And those don't simplify to anything. Okay, so A minus B over A plus B does not simplify to negative 1, nor does it simplify to positive 1. So just be careful when you're canceling in general to make sure that you're canceling terms that are exactly the same or terms that are exactly opposites, and only those two things. Good luck in this section, everyone.